welcome to, I guess this is the last show for drinks. So my name is Zubin. I head up innovation and development at Mu Sigma. Basically our Mu Sigma research labs, I head that up. Have any of you guys heard of Mu Sigma, by show of hands? Only a few of you, okay. So Mu Sigma, we're the largest decision sciences, pure play decision sciences company in the world right now. All we do is analytics, and that's basically what I want to share with you from the field, from really the front lines. What are the top shops doing? When I say shop, I mean an analytics shop, analytics departments in the field. And so what I'll be sharing with you today is, the insights I've gained from the years of working with a lot of our clients internally. I basically live on Delta Airlines, and I travel to client to client to client to client. So a lot of these insights are going to be from Fortune 500 type companies as well, just to give you some feeling of where the sample size is from. But the bottom line, what I want to share with you today is, what is going on in the analytics space, first of all, just kind of high level, some very important trends you guys, everyone should be aware of. And not only big data, there's some other very important trends you need to be aware of to really run a top shop in the analytics services or the analytics area today. And then we'll go into some reference designs. I think a lot of you may be here for that. We'll talk about some best practice designs we're seeing for an analytics technology stack, as well as some other interesting ideas that you guys should be aware of as well there. And then we'll finish up with how to scale analytics. The bottom line here, the technology that we're seeing and talking about today, Hadoop, for example, it's all about scaling analytics. And it's not only about machines, it's also about humans. And there's an interaction there, and we'll talk about how that works out. So that's basically the agenda for today. Okay? Feel free for questions, I guess, when you just come up to the microphones if you like. So if you look at right now in the industry, I've been in the business 20 years now. I've never seen anything like it in the last 2 years. It truly is a renaissance that's occurring in the analytics industry. It's a rebirth. What's causing it? Well, Hadoop, I think, is a technology trigger, a big part of that. But we'll talk about some other reasons in a moment why we think it's really booming like it is. But if you look around, what we're seeing is we're expanding applications everywhere. The mindset of the business is just expanding with new ideas that they're reading so much about big data, and they're getting a lot of insight and inspiration from those readings and want to apply those in the real workplace in the enterprise. We're seeing data sources exploding. We all know that. We talk about that here in many of these conferences. Advanced analytical techniques, now they've been democratized as well. And so using like R, for example, all these techniques are available. And there's really no excuses anymore as an analytics practitioner not to be using more of these advanced techniques. As well as technology evolution, which again is a big part of this conference. And again, we'll talk about how Hadoop fits into this. So when you look at this ecosystem, and you focus on the consumption of analytics, not the creation of analytics. So what I mean by that is what really differentiates an analytics shop, the success of the analytics shop, is not the amount of analytics they create, but it's the amount of analytics they consume, that gets consumed by the enterprise. And that's really the key differentiator. And when you look in that area, you see a lot of important trends. We track about 22 micro trends right now in this space. If you aggregate them up, do kind of a mental factor analysis, you get 3 macro trends. And we recommend every single analytics practitioner, every single analytics department have an agenda in these 3 areas. And we'll talk to you why in a moment. But I want to review just high level some of these trends. Then we'll double click down into big data. So the first trend we're calling it computational enablement. And the big data and the NoSQL trends and NoSQL technologies fit into this computational enablement trend. And basically the spirit behind this is real simple. It's about the democratization of essentially supercomputing, right? Parallel distributed computing on commodity hardware. That's a real big piece of this computational enablement area. And it really is enabling the usage of advanced analytics, the usage of analytics at scale within a company. So that enabler is a very important word here. It's a computational enabler. And there's other things that are going on. You see master data management rising up. You see this whole idea of a central enterprise data warehouse. Never, in all my years, I've never seen the central EDW really be implemented the way it was planned to be. However, listening to some of these talks, I hear data lake and data reservoir. That sounds a lot to me like a central enterprise data warehouse. And it's interesting how it's cycling back with respect to Hadoop and HDFS. Other things that's important just to call out in the computational enablement area is this disruption between ETL and ELT. And we'll talk about that, why that's so important for an analytics practitioner. And that really goes down to the agility side of the house. So computational enablement, big trend. I think we're all pretty familiar, especially the audience here, we're familiar with that one. The other one that's really big is we call UV for short, usability and visualization. What's that about is aesthetics and design that's coming into our field, right? And so how do you design an artifact for that people will consume? You have to use some design elements. And that all affects the consumption of these artifacts that we give our clients or we give our users. And that usability and visualization trend is very important there. And that's a real big trend. You're seeing like the rise of this whole technology tier on advanced visualization, like a Tableau that we're seeing, like a Spotfire, like Panopticon that just got purchased last week, like SAS Visual Analytics. These are all new tools that are coming into beyond what I call the boring BI tier, quite frankly, and got to the advanced visualization tier. Now, last but not least, another very interesting trend is something we're calling intelligent systems. And if there's any Fifth Element fans in here, there's a quote from Fifth Element that kind of nails this. And it basically states, anticipation denotes intelligence. Anticipation denotes intelligence. And that's basically what intelligent systems are about. You're building out anticipatory systems, which is predictive analytics, and you're operationalizing those. You're getting analytics out of PowerPoint, guys. Get it out of PowerPoint and get it into the operation. That's really the name of the game, and that's what intelligent systems is about. And so I hear a lot of talk about events and streaming, and that's exactly where this falls into play, complex event processing, dealing with data before it's actually even persisted into a database as it's streaming. How do you handle that? How do you do a machine learning algorithm? How do you do a basic regression algorithm or statistical method on a streaming data set? It's a different type of physics. We'll talk about that as well. So those are just three big trends I just wanted to make sure you guys are aware of. Big data computation is within the computational enablement realm. It's quite important, but there's some other ones as well. We get this question a lot, why should we care? So first of all, analytics, why do we even care about analytics? The bottom line with analytics, it leads to decision support and decision sciences. It enables people to make better decisions. This competitive differentiator is kind of important. I was working with a very large retailer, bless you, a very large retailer. He has about a $2 billion spend in marketing. And he said, Zubin, think of me as a professional gambler. So what do you mean you're a professional gambler? Think about it this way. You need to give me an edge. And analytics will give me that edge. You need to provide me a way I can allocate my budget accordingly and give me an edge in the marketplace. And I thought that was a very insightful quote about what analytics is about, and, in that whole kind of competitive differentiator and the executive as a professional gambler. Consumption, I mentioned what of analytics differentiates. I've mentioned that. It's so important to understand that, especially in what I'm calling the top tier analytical shops. They really get that. That's really all they care about is the consumption of analytics. And bottom line, guys, it's about scale. Hadoop and the frameworks around Hadoop are providing us scale. It's providing the analysts, the analytics analysts, the ability to remove all the excuses they had in the past with respect, I don't have the algorithms, or I don't have the budget, or I can't compute this fast enough. A lot of those excuses are being eroded away. Okay, a couple of things about big data. The technology trigger, of course, but when you see a lot of analytics shops in the market, in the enterprises today, there's a frustration trigger. And so I think this was a big, kind of a big, important element to its popularity in the enterprise. And what I mean by that is something called the tyranny of the data model. I don't know if you guys are on the analytics practitioner side, but every time I needed a new data set or a new field, I always had to go to IT, and IT said the dreaded word, we need to build a data model, okay? And that translated to 3 months. Whatever I heard data model, it meant 3 months delay, right? And for an analytics enterprise, or usually an analytics department, there tends to be some tension between the analytics department and IT because of that. So there's a lot of frustration that was pent up. And I think these new tools that we're seeing really liberate the analysts and let them be much more agile and ingest data in many forms. It's just a quite exciting time. It really is a renaissance. All right, so I just want to leave you with this quick framework. This was, this is not my idea. This is from Andreas in Stanford Social Data Labs. But data set, tool set, skill set, mindset, okay? Data set, tool set, skill set, mindset. Big data, when people ask me what it is, I say it's a metaphor for disruption, in essence. It's disrupting these 4 dimensions. Data set, we know about. It's disrupting. We can analyze unstructured data. We can analyze much larger data. Tool set, we've talked about that a lot in this conference. It's disrupting the tool set landscape like I've never seen. right? It's amazing what's going on there. But again, those are the more the machine side of the things, data set and tool set. It's also disrupting the skill set side. For example, I'm hearing in a previous discussion that there isn't enough data scientists. And basically, that's what Musigma is all about. We have 3,000 analysts, and we supply data scientists to enterprise companies. But the skill set has to be basically disrupted as well. It's a different type of tool that's required nowadays in this parallel distributed world. Most importantly, though, most companies that get through those three, the hard one is mindset change. Mindset in the IT departments, mindset in the CXO level about what I can do with all this data. What can I do with it now? And that's taking some time to change. Quite frankly, that's the hardest thing to change in corporate America today is the mindset about what we can do with this data. Okay, so let's get into some reference designs. So let's talk about the ecosystem. Right now, you can see by this diagram, there are a lot of vendors. And if anyone says they know what's going on at any point in time, I think they're fibbing. Because there is really no way, like just coming here, there's new technologies popping out left and right. And so there's a mindset, again, it's a knowing versus learning mindset. You really can't say, you really got to move to a learning mindset, not a knowing mindset. Sometimes, I don't know is a good answer. So a learning mindset, what that means is that I have a test and learn kind of philosophy. I go and learn and experiment. And I've heard that term experiment a bunch in this conference, which is very interesting. But it's, again, migrating from this knowing mindset to a learning mindset, which I think is quite important to really stay abreast with what's going on in this big data ecosystem. We do a lot of qualitative, dozens and dozens of Fortune 100 companies. When we ask them what they think a next generation analytics platform will be, these are some of the VOC keywords that we're seeing. And the ones in red are the ones that come up quite frequently. So scale, folks, the analytical departments, analytical shops, I call them, want to scale. Value, they want to scale without paying a lot of money to vendors, right? They want to be able to scale their computational resources, computational enablement. Batch and real time, they want to be able to do both. Agility comes up a lot, right? They want to be able to create their own data model. They want to be able to join these two tables together. They want to be able to do some transformations on the fly. It's more of an enablement and an agility metaphor. Automation, we'll talk about. That's a huge one. And it's missed by many companies. We'll come back to that. Open standards, champion, challenger. And again, this data model comes up a lot, beyond this tyranny of the data model we've been calling it. So that's the qualitative. So, but more importantly, though, you start thinking about why analytics is here. It's about making decisions, improving the decisions, giving us an edge on the decision side. So you get into the decision support area. And we've basically started introducing this paradigm or this framework to start thinking about how you organize all your technology for an analytics shop and how you evaluate if you have you've thought about all these elements that we're seeing from the synthesizing from all the top shops that we witness in the US, in Australia, and in Europe. And so what we've organized this out is in three major tiers. You've got a technology tier we call data engineering. Right? We've got data science layer, which adds math and technology. So you've got technology, math and technology, and math, business, and technology. And that's the decision sciences layer. And in the next slide here, we'll talk about the specifics in these areas. And then we'll also talk about where companies are really, really deficient, where people are missing the boat, where quite frankly, a lot of you are missing the boat, where you don't really see there's an area here that's quite important for the analytics practitioner, for the top analytical shops that are in production with algos, right? So let's talk about it. So data set, we've got that coming down at the bottom there. Then you've got this data engineering tier, right? Which is basically very technology focused, where you've got your ETL, your data integration layer, a lot of vendors in that space, Informatica, Omnitio, there's Talend, the open source, there's Pentaho, Kettle, et cetera. Microsoft SSIS, et cetera, et cetera, et cetera. And then you go up to this data and HPC layer, which is your compute and persistence layer. Now that area is where we're seeing a lot of innovation, quite frankly. SQL, NoSQL, GPU. We're seeing also for the top shops, they're not only using the CPUs in the clusters, they're squeezing and using GPUs as well in the clusters. So that's an important trend that I haven't seen a lot here, but the GPU side as well. Clusters, which we talked about, computation, event processing in memory. These are all the compute and persistence technologies that we're seeing today. And so that area, in my mind, is very blurry today. And some of the folks we're talking to really think this will evolve to really two areas, the compute and persistence layer. They really think the persistence layer will just be an HDFS or equivalent or the next generation HDFS, basically a commodity style, parallel distributed framework for your file system. And on top of that, all it will be is a very large in-memory compute device. And that's really it. That's where some people are speculating where the next persistence and compute layer for the analytics area will be, all it will be. It will be this really interesting parallel distributed framework for your persistence layer and a really large in-memory compute engine. As memory comes down, as SSDs comes down, it's an interesting idea. Okay, so that's the data and HPC layer. Above that, now you can think about each one of these layers and how well your company is actually providing services there, or how well are they covering these things. And so far you're saying, okay, check, check, check. We're doing a pretty good job so far. Business contextual layer, your semantics, your ontologies, your metadata. The classical data warehouse shops do a pretty good job there. The Hadoop field is very young in that spot. So the business contextual layer, I think, it's just starting provide its technologies in the Hadoop infrastructure there. Shared production layer is another one within data engineering, where you're getting shared web services we're seeing for some of the top shops, where they actually push out their predictive algorithms of services that the rest of the company can consume. Production support environments, those are more in federated shops, where we would recommend where people are building out building out a federated support model for their analytics versus a centralized or decentralized. We'll see a shared production layer with support and administrative support, or in even training and help desk there. Security and repositories. So that's all in this data engineering layer. And most companies, check. I think most people get that area pretty well. Then we start adding math, okay? Adding math. Then you get into what a lot of the platforms and data mirrors and all the BI vendors are basically targeting, reporting and analysis, right? Hopefully, with all these new technologies, we don't have to build cubes anymore. And we move beyond the cube metaphor. But then we also do advanced analytics, right? So this is adding more multivariate techniques, some of the machine learning techniques. So SAS is a dominant player there, but also R is a dominant player in that space as well. We're also seeing some Python jumping in that area as well, but I'm seeing SAS and R as the dominant players in the advanced analytics space, but not in the Hadoop land. It really is Python and R for advanced analytics in the Hadoop space. And then dashboards and visualizations as well. So that's in the data sciences tier. So far, most companies check, check, check. Okay, they do pretty good jobs in those areas as well. All right, so this is where the hole is, and this is where a lot of people are missing the boat. And we're gaining these insights from really the top shops. When I say top shops, these are the shops that are doing, for example, in the finance industry. They're doing the quants. We're looking at the high-performance CRM shops, like the banks and some of the big casinos. These folks are really get it. They really get decision sciences, right? And they add this layer. And I really want to drill down into this layer because it's so important, and especially for the engineers in this house, that maybe we start getting some technologies in these areas for the Hadoop stack, all right? So one is called consumption enablement, and that whole area there is about a proactive agenda to get your analytics consumed. And we'll drill down into more of these so you guys have a good feeling. I'll show you some examples of what that means. But it's about building these intelligent systems, which are much more, in that case, much more machine-based, or machine scaling with machines. It's about developing very good user personalization. It's really that UV trend coming in here, aesthetics, design. Having an agenda around consumption enablement is quite important, okay? That's to scale. I'm talking about how to scale decision sciences. Knowledge management. That's a huge omission. All right? Most companies don't do anything with knowledge management with respect to the analytics tier. All right? What I mean by that is, after I've completed an analysis, right, I persist it somewhere where it's self-contained, where all the code is there, the presentations are there. Everything that's needed for a new person to come evaluate and learn about that project is there. Right? So you're building this corporate memory, this enterprise memory of analytics. And then you can start doing meta-analysis, so analysis of those analyses themselves over time. And that's really how you can really scale and persist a lot of knowledge in the company in the analytics domain. So that's another area that's under decision sciences that a lot of companies are not doing. And last but not least, probably the most important to scale analytics is process management. And we'll talk about that some more as well. But that's all about how do I automate an analytical, and how do I orchestrate an analytics process? We see a lot of automation in the ETL layers today, right? Source to sink mapping, nice drag and drop interfaces to map those things out. But we're not seeing any of that stuff really in the analytics domain, where you have man-machine interaction. It's not just a miner product. It's not just enterprise miner or insightful miner or NIME or something like that, right? It's more than, those are more tools to build out a model. But how do I operationalize and productionalize, and how do I scale a model so the humans don't have to be so involved? Time and time again, I see analytical shops that have what we call the golden handcuffs, all right? And what that means is that over time, they start becoming successful. They build a model that the company wants. They build a report that their internal constituency wants, right? And over time, they've got this legacy behind them of all these reports and models that they have to support. So over time, they don't want to innovate anymore, right? Because they know the next thing they do, they have to service it. So how do you break that, right? How do you break that and really get that automation on the analytics tier? And we'll talk about that's process side. And then the presentation delivery tier, again, where design comes into play again. The art is coming into the science here. And that's and some of those design metaphors, which I'll share with you in a second, are omitted. A lot of people don't get it. All right, so bottom line, here's a reference design. I think it's an interesting, very elegant way to kind of represent a decision support stack. Basically, analytics is about making decisions. Technology, math, business and technology, decision sciences, and data engineering. Okay, because it's a Hadoop conference, I wanted to distill some insights from dozens and dozens of implementations we've done in this area and kind of give you a best practice reference stack of what we're seeing people are doing. Again, this is Fortune 500 companies. These are your suits, I think I saw in an earlier meeting, not the hoodies, right? Okay, and this is what we're seeing this is kind of what we're seeing over and over again. So just so you guys can see on the left-hand side, or your right-hand side, or your left-hand side, data sourcing. So people have all their data sources that are trying to get into the Hadoop area. They're importing through, and I'm seeing Scoop use a lot there as well to pump data into HDFS. And people build this kind of this edge node out here where they use Uzi to do some workflow automation to kind of schedule these jobs and get them running and pumping the data into their Hadoop infrastructure. So you have Hadoop, MapReduce. I can't wait till we can use MPI because especially from my background is all econometrics and advanced analytics, and MapReduce isn't really good for that kind of stuff. We much prefer MPI to do that. And so we're waiting for Yarn. We're really excited about when Yarn gets released. So you've got NoSQL DBs, you've got HDFS, you've got some ELT, ETL, and then we're seeing folks, the best practice areas, we see a batch and real-time area. And I think there's actually a term for that, having real-time and batch together. I think they're calling it Lambda architecture now. But you have this real-time capability and a batch capability. Now, what most companies are doing, actually, are they're taking this information, they're using Hadoop to create structured tables to pop back into their EDW. All right? And then they're, on top of that, they're having the BI tools that they have, and you can see a bunch of them there, just hitting the EDW now. So they're using Hadoop as this big processing engine to push into the relational model. Now, we are seeing some clients now going straight to Hadoop, and some of the new tools can hit Hadoop directly, like the Plat4s, the data mirrors, the Tableaus now can start hitting Hadoop directly. And we do see over time, direct connections into HDFS. But again, I'm talking about the Fortune 500 companies, and they're not there yet, okay? And then you're exporting data back out to the traditional EDW with Scoop as well. So this is a kind of a reference architecture, a best practice we're seeing in most companies today. I don't know if it's the best practice, but this is what we're seeing people are doing. Okay, so what I want to take you now is kind of double-click you through some of these areas that are so important that people are, that the top-tier shops are implementing. And I want to take you through what they're actually doing in these areas. Okay, so the first one is consumption enablement. And what's happening here is one big trend is dashboards, okay? Bottom line, I call them dash boredom or dash boring. Dashboards, I wish people would stop building the darn things, all right? So the bottom line with dashboards is, yeah, you're giving me information, right? But think of another metaphor. Think of this cockpit metaphor. Don't just build me a dashboard, please. Build me a cockpit. Give me simulation. Give me optimization. Give me a way to intervene with the data. Don't just give me a way just to see the data. All right? So what we're seeing, some of the best practice folks, again, in the frontier industries, again, finance is always in the frontier industry and analytics, they're actually building cockpits. They're intervening with this information. So that's an important, I think, takeaway from the consumption enablement side is, again, don't just build dashboards, build cockpits. Another thing is, quite important is this aesthetics and design trend that we're seeing. D3, I love D3. You need to get inspiration. There is an art to this now. There's not just pure science. You're dealing with human beings that need to be convinced they should utilize what you're providing them. You know, when you're dealing with machines, it's much easier. But when you're dealing with humans, it gets stuff consumed on the analytics side. You know, things, unfortunately, have to look good. Beauty is sometimes trusted, right? And so it's important to have aesthetics and design. And you have to get inspired. Like I said, you know, D3 is one of our favorite frameworks to get inspired. There's just so many very nice widgets out there. But also, you know, the movies you watch, the sci-fi movies you watch, the Avengers, Iron Man 3. A lot of this stuff, especially with natural user interfaces, can be done today. You can get to these things. And so these are the kinds of things you can start experimenting with. So get inspiration from areas as well. That's kind of the idea there. Okay. So a couple of things I want to share with you again on this consumption enablement is, well, can I go backwards here? Let's see. Okay, so visual perception, you know, this is, okay, we know this. The eye can process the most information. But there's some interesting frameworks. You know, you just can't rely on your tools to enable you the aesthetics and the design that you need to get something consumed. So I want to share with you real quickly some important design frameworks that you all should be understanding so you can critique, go back and critique dashboards and cockpits that are built. For example, how many threes are in this matrix, right? That's a question I'm asking you. So right now, what's going on, you're using what's called your focal attentive processing centers in your brain. You're scanning serially. Right? You're not doing a parallel operation here. You're scanning serially and trying to count the number of threes. It's very slow. That's number one. And number two, using short-term memory was also very slow. Has anyone got the number of them? 4? 3? Anyone? 5. Okay, good. There's some variation here as well. All right, and so, for example, if you're running a streaming data set and you want people to visualize a streaming data set, you don't want to show your data like this. So what's going on? So let me show you something now. I know this is trivial, but watch this. Now how many threes? Pop. All right, it just popped. All right, you just had 5 was the correct answer, and you just witnessed what's called the pop-out effect. All right, and that's called pre-attentive processing. Right, so what you need to do is, that's a biological thing. That's something biological that's in part in the human being, pre-attentive processing, that we've evolved for, you know, all the years we've been on this planet. So you need to understand those things, take advantage of those things to aid consumption enablement. So I'm telling you guys, it's not as easy as just throwing out a dashboard. You have to understand some of these frameworks. Right? And so pre-attentive processing, I've done a lot of the homework for you. It's big in academia. There's 4 key dimensions: form, color, spatial, motion. Form and color, most of the vendors get that. Spatial, especially with graph methods that we're seeing is getting real popular. Spatial methods are starting to become more utilized. And then motion. Motion is something still not completely utilized to deliver these pre-attentive processing elements. So that's one takeaway. Another takeaway, I would recommend that you all go to Tufte's classes. I think he's coming out here pretty soon. It's only $380. I don't have any affiliation with him, but it's only $380, and it's the best $380 you spent because you get all his books as well. All right? And you have to learn some of his frameworks. Eloquence through simplicity, the Tufte data-to-ink ratio. All right? For example, if you look at that on the left-hand side here, that chart with gray background, it's not maximizing the data-to-ink ratio. The one on the right is much more aesthetic. Right? It's much cleaner, and it really proves the story that it can help the consumption of analytics by doing some aesthetic changes. And you want to maximize those data-to-ink ratios. So it's all about simplicity and eloquence, and that's some of the stuff Tufte teaches. Other things you just need to learn real quickly. Back in high school and undergraduate, principles of art design, right? Especially if you're building visuals that people need to consume, what people really miss is this emphasis on focal point and balance. I don't know how many dashboards I've seen that have 4 equally spaced widgets, right? You're not giving me a focal point. You give me no way to start the interaction with the data. That's a mistake. You're not enabling consumption. And so this idea of decision sciences, enabling consumption enablement, again, these are some of the frameworks you should be familiar with. Now, given that you've known that, I'll give you an example. So do you guys think this is good, bad, or ugly? Given some of the frameworks you learned. Data-to-ink ratio, eloquence, design, what else did we learn? Tufte's data-to-ink ratio. We've also learned about focal points and pre-attentive processing. So what do you guys think? This is good, bad, or ugly? Bad. Yes, it's terrible. It's not just bad. It's very ugly. You know, what's going on here? You've got all this ink where the data is not there, right? So you're minimizing the data ink ratio. You're not maximizing it. You've got no focal point. I don't know where to start looking, right? And then you've got these crazy colors in the US here that I don't even know what's going on, all right? So this is a very bad example. So let me give you another example. This is a very good example. It's clean, you're maximizing data ink ratio, you've got a focal point, and we're seeing that a lot of people are decorating around the borders, more drill capability, more information. And you'll see that in a lot of the vendors today, like the Spotfires and Tableaus, they use this model. So I just wanted to leave you with that information as well. So consumption enablement is important. There's some really real frameworks you can learn in this area to try to enable and boost that. Okay, so let's jump to knowledge management. So some of our key clients that are doing this, they're using this product right here. It's called DSpace. I don't know if you guys anyone's heard of DSpace? So MIT provides this for free, and it's a really nice tool to archive all your analytical work. It works fabulously. It's very well supported. And it looks like this. For example, you create communities. You're basically using a library-based tool that you go to your university library to search for books. You're using that to search your analytical reports. You're archiving all your analytical work that you've done. And some teams have actually hired librarians as well to manage these things. That's how important it is, knowledge management to these folks. All right? Another idea, like in my department, we use a wiki. Right? We create a lot of white papers in our labs area. And for example, we have a list of all these white papers that are all accessible, and I can search them very rapidly. But then if I click through them, you'll notice that there's a PDF, but there's also there's an RNW file, which is, I'm a big R user, so that would be a Sweave or a Sweave file, or LaTeX for those folks that know LaTeX. Also knitter, which is also quite popular now in the R world, to create what are called reproducible analytics or reproducible reports. So what I can do now, I can see the PDF, but now I can see all the code that generated that PDF. I can compile to a PDF, and all the code is in there, all the text is in there. That's why they call it Sweave. I'm weaving together S, which is the old R and text together. And all that's in one document, in a compiled, programmable, reproducible document. So now I can reproduce that analysis very easily. I can see all the source code. It's documenting itself. A very nice way for knowledge management, knowledge retention. I can scale analytics now. I can quickly query this repository, learn how someone has done something, and then continue to scale out my analytics agenda. All right, so you see the power of the knowledge management area as well. Okay, process management. Let's talk about that a little bit. So a lot of folks we deal with, we see this, they show me a flow chart. This is how we're doing analytics today, Zubin. We get a request from a client to generate some analytical work. We get this email. We'll query Teradata, right? Then we'll take that data, put it in Excel. Then we'll run SAS. Then we have to do some optimization, so we'll run Cplex over here. Then we take all that stuff together and we run SAS again. And then we'll output it with VBA and Excel back to the requester, okay? And that's why an analytics department cannot scale, because there's a lot of human elements here, right? And if I have to run this over and over and over again, my whole job will be just running this process flow. Right? There has to be a better way. There has to be a better way. All right? So the idea here is there's a lot of BPM tools out there, right? And a lot of folks already have BPM tools. And BPM tools have been relegated to the back office, doing expense accounts and things like that. But they're extremely powerful if you add analytical components to them. You add a SAS node, you add an R node, you add a SQL node, you add a Hadoop node. You add analytical nodes into the process workflow, into the tool that you have. Right? It's very easy to do. And once you do that, you have a beautiful tool, business process modeling tool, that can interact with humans, it can interact with machines, and you can orchestrate a process very elegantly. Right? The whole idea here, if you can see, I don't know if you can see the pyramids, but you've got operational analytics at the bottom, tactical and strategic analytics. Most of the folks in departments today are spending a lot of time on operational analytics, which is basically just scoring and reproducing automated stuff. But humans are doing it. But using a tool like a BPM tool with analytics components that you can orchestrate, you can really squeeze down the operational analytics, let the machines do that, and let the humans do more strategic and tactical analytics. And this is, you can see a screenshot there, you see some nodes. There's an open source tool out there called Nexus BPM that does this. So if you want to check that out, there's also a tool that we've built called, that we base on the activity engine. So we take open source engines, add analytics components to it, and we have a very nice tool that we can elegantly scale analytical processes, okay? So that's important. So it's not only, you can't just put a Hadoop system in place and expect all this productivity. Yeah, you put a Hadoop system, you can scale a problem. You can scale it once. But now let's say I'm in production mode. I have to run this over and over and over again, all right? What do I do, all right? This is why this is so important. Now, the last but not least thing here that professional shops require is what's called model management, all right? We're entering in, some of our clients are entering into algo wars. They're actually differentiating by their algorithm predictability. And so you have a whole lifecycle management around an algorithm. You have, it parallels the software development paradigm very nicely. You've got dev, test, staging, production in algorithms. You've got version control in algorithms. You try to stay vendor agnostic so you can import your models, and a lot of people are using PML, Predictive Modeling Markup Language. So you've got lifecycle management around a model. You've got continuous performance and model management in production. When you're in production with algorithms that are doing predictions, they degrade over time, especially if you're dealing with human beings. So you have to develop reports that monitor those things and have exception-based reporting when they start to degrade. You have to have champion challenger models in market, where you have a kind of a Darwinian battle between models, and the ones that are doing the best are winning on a champion, and are constantly being challenged. So there's a whole paradigm around model management that I see not talked about very well in most analytical conferences today. So that's, and SAS actually has a product there called Model Manager. You can get a lot of good ideas there. But again, the top tier shops, they're doing this. This is how they live and die by model management. Okay, so 4 minutes left. I want to take you real quick a little bit about how to scale analytics, this intelligent systems trend. It's so darn important. I just wanted to kind of share with you a little bit of anecdotes here. When you look at, for example, in this case, I want to optimize some of my website here, and I've got a customer buying a laptop, and I've got all these things that are going on. They're going to the web page, they're adding to the cart, they're checking out, and we've got some behind-the-scenes stuff going on, and we email them. And around the periphery there, you see there's a lot of opportunities for analytics, for advanced analytics, for optimization, pop-up optimization, collaborative filtering, which is recommender engines, offer optimization. In the marketing space, this is why marketing is real big in analytics. There's a lot of opportunity there. Now, you have to get beyond the batch paradigm. There's no way you can do all this at scale by having humans behind here, creating SQL and scoring, creating a SQL job that runs every week to update the database. There's no way you can scale with the level of complexity and level of analytics that's required here without building what's called the intelligent system paradigm, which is using more machine, relying more on machines to scale out your advanced analytics. Okay? So that's the point there. So again, the whole thing with information, intelligent systems, is to remind people we are in the information age. We're not in the industrial age anymore, right? And you have to figure out how to really compete with computation, which I think this audience will agree that's quite important. So, just some current news. I don't know if you guys are aware, but a lot of the complex event processing vendors all got bought out last week. So Streambase, Timco bought them. Progress, Apama, which was really strong in the financial world, got purchased by Software AG. Why do you think they're purchasing them? This trend is very important, this event-based trend, applying analytics to an event, stream of events. It's quite important. And there's a lot of stuff going on there. GE is doing a lot there. If you get this deck, just click on and watch that video by Jeffrey Emmelt. You'll be quite inspired about, and analytics is not just for enterprises. It's really going into this machine realm, which I think a lot of the machine-to-machine data sets we see here, you guys would appreciate. And there's some really good books as well that you could read in this area. So one thing I want to share with you, a high-level design for building out intelligent systems. This is what we synthesized and what we built in our labs. So basically, we have this, this UI tier that's GUI, also works on tablets and everything. It's all HTML5 JavaScript. Then you've got an abstraction to the service layer, but then you've got this ESB. ESB is very important. And then you've got a real-time and a batch system. And then you integrate to R, SAS, business rules engine, and Hadoop, beyond the firewall, a relational database, in-memory database. These are all elements that you can orchestrate and utilize. You use BPM, like I was telling you about, to orchestrate the process flows in batch. And in real time, what I see not a lot of people talking about is we use the agent paradigm. Software agent development, multi-agent paradigm. It works, why we chose that, it works very well in the analytics realm. Why? Because I have data flowing into the ESB. I have agents that are listening to those messages coming in. I form an abstraction called an agency on top of multiple agents working together. Now, why it's really elegant for the analytics space is because I'm putting in a model in market Then I have other agents looking at the model's prediction and tweaking the model parameters in real time, right? And I can have optimization as well. I have agents optimizing these parameters in real time. So I've got this, I deploy an agency of agents that are looking at the stream of data coming through and manipulating the stream of data with functions and then pushing out into the output. Now, that's something, if you guys are interested in, it's something we work on a lot in Mu Sigma Labs. We're actually releasing a tool called RJade. So Jade is the underlying open source technology here, Java Agent Developer Environment. And we've added R capability inside of Jade Agent. So it's a beautiful complex event processing metaphor because R is an in-memory system, and you can leverage all the sophisticated algorithms and packages in R to manipulate the data that's coming through your stream. Okay? I think my time is over. Perfect. Any questions? Questions? Analytics, next generation. Sure.
You had something called, don't forget the fourth tier, it's juicy.
Yeah, it's juicy. Yeah, so a lot of folks will forget is they'll build out a data tier, a middle tier, and then a UI. They'll forget about the advanced analytics tier, the optimization algorithms, give me a way I can run a regression model, a factor analysis, multivariate methods. They forget the optimization, the analytics, advanced analytics tier, which is very important. I can squeeze a lot more value out of my data with those techniques. Questions? No? Okay, guys, thank you very much. We'll see you.